What up? It's Kettlehead, and welcome back to another video. So today we're going to finish up the parallel perpendicular notes you got. You should be getting these on May 13th, I think. No, a little sooner than that, maybe. That's the wrong calendar. Either way, these are for the week before the last week of school. You'll see it in the module. It doesn't really matter. But anyways, you should have already seen parallel perpendicular. If they're parallel, two lines have the same slope. That means they're parallel. Perpendicular means negative reciprocals, which is what a couple of these are that I'm writing on the screen. You flip it and change the sign. So for example, 1 and -1 are the only ones that are strange. All the rest of them are -2/5 and +5/2, 3 and -1/3, etc., etc. Or neither is also should be on here. If they're neither, that means it's not one of these groups and it's not the same. So you always should put these in slope-intercept form. To do so, it's y equals mx plus b. So for us, this first one is -3 is our slope. And the second one here, our slope is 1/3. Again, you don't take the x with it. This should be old news. This should be no problem here. So just identify the new part is whether they're parallel or perpendicular. Are they the same? No, so they're not parallel. Are they perpendicular? Well, they have to be negative reciprocals. So you can either start to recognize that, yes, this is in fact negative reciprocals. These are perpendicular. Or you could start and just do math. So first things first, you flip it. So I start with -3, I flip it. That turns into, remember, if there's nothing below it, it's like -3/1. So you flip it, that changes to -1/3. And then change the sign, and you get +1/3. So you notice our original slope, you flip, change the sign, you get the next slope. That means they are in fact perpendicular. So flip it over, change the sign. If they match, then if this matches this, that means they are perpendicular. Right? Negative reciprocals. These, again, you'll notice are already written in slope-intercept form. You notice this because you should all know what y equals mx plus b looks like, but y is by itself. There's nothing in front of it. The slope for the first one is 5/4. The slope for the second one is 5/4. They are the same. This is the easiest one to recognize. Anytime you have two things that are the same, the slopes that are the same, that means these are going to be parallel. This is a good time to point out something else, though, that you might see on Alex. You have to look at the y-intercept too. These are different, which means these are different lines. If you had the exact same equation, like if I had two of these, if they matched, like if they both said 5/4x plus 1, and this one was 5/4x plus 1, those are not parallel because they'd be the same line. So that's another case that we would say coincide. But that's something I don't know if it comes up in the homework, but if it does, that's probably what they're looking for. Or they might also take neither, because technically, if it's parallel, perpendicular, or neither, well, they're not parallel because it's the same exact line, and they're not perpendicular because they don't intersect at a 90-degree angle. So, okay, so here we go. Two new equations. This one's already in slope-intercept form. Our slope is -3/2. On this one, you have to put in a slope-intercept form. So to do so, you want to get the y by itself. So to do that first, you have to move this 3x to the other side. Opposite of plus 3x is -3x. Subtract 3x from both sides, and it doesn't matter if you put the 3x in front of the 6 or behind it, either way. Technically, if you're doing slope-intercept form, this should be in front of it, but really it doesn't matter. Divide both sides by 2. Why? You want to do the opposite. If this is if this is multiplication, you want to do the opposite at, which is division. Divide both sides by 2, and you get y equals 6 divided by 2 is 3. -3 divided by 2 is -3/2. So notice now our slope for the second one is -3/2. And these two things match, which means if they match, they are parallel. Right? So this is going to be the same story, but neither of these are given in slope-intercept form. So first things first, let's do this one. It's a little bit quicker. To get y by itself, you just have to divide everything by 3. 3y divided by 3 is y. That's why we do it. 4x divided by 3 is 4 over 3x. 4 over 3x. And then 15 divided by 3 is just 5. So our first slope is 4/3. Same thing over here. You want to get y by itself, which means we have to do some work. First, the 12y has to be by itself, so this 9 has to go to the other side. Opposite of plus is minus. Again, it doesn't matter which side of the regular 12 you put it on. So I'm just going to do 12 minus 9x. If you want to put it in front, go ahead. So I subtract 9x from both sides. Those cancel, and I'm left with 12y equals 12 minus 9x. Now you have to get y by itself. Divide both sides by 12. You get y equals 1. 12 divided by 12 is 1. Negative 9 divided by 12 is negative 9 over 12x. Anytime you see a fraction like this, you should always reduce it whenever you can. If you already reduced it, good on you. So negative 9 over 12 reduces to negative 3 over 4x. Now you notice these slopes don't match, and you might be tempted to say it's not parallel, which is correct, and then you might also just say neither, but you do have to see if it is the negative reciprocals, in which case you can take either one and start with it. So if I start with the 4/3, first thing I do is flip it, and I get 3/4. And then I change the sign, and I get negative 3/4. And we see that negative 3/4 matches over here, which means these are negative reciprocals, so they are perpendicular. If you want to do it the other way just to prove to yourself, you can. So if you start with negative 3/4, first you flip it, and you get negative 4/3, and then you change the sign, and you get positive 4/3, which is where we have over here. So these are perpendicular. You should eventually you'll start to recognize 4/3, negative 3/4. They are, in fact, negative reciprocals. So these two, kind of just doing the same thing again. Y by itself is always the goal. Y should be positive as well. You shouldn't have a negative y. So this one I'm going to do a little bit different. So if you look at the one on the left, I'm going to move 2y first. So I'm going to have 10x. The opposite of negative 2y is plus 2y to both sides. So 10x equals 16 plus 2y. Now we want to get 2y by itself, and it's positive. You don't have to move it. If you don't mind the negative, leave it there. So I'm going to subtract 16 from both sides. I get 10x minus 16 equals 2y. And then to get y, opposite of multiplication, division. And this is all algebra 1. So if you have trouble with this, you need to go talk to your algebra 1. So first, our slope here is 5 then. So our slope is 5. Over here, we want to get y by itself. So I'm going to subtract x from both sides. I get 5y equals negative x minus 20. And then I want to divide both sides by 5, because that's what's in front of the y. I get negative 1/5 x minus 4. So our slope is negative 1/5. 1 over 5, there we go. So you might recognize this already, but these are negative reciprocals. So if you see that, then you're good to go and say perpendicular. If you don't see that, you can start with 5. Remember, if there's nothing underneath it, there's secretly a 1. If you flip this, you get 1 over 5. Then you change the sign, and you get negative 1/5. And you notice those, where you start, where you end, are the same after you flip and change the sign, so they're perpendicular. Last but not least, quick video today. These look pretty similar, but let's see what they do. First, I want to get y by itself, so opposite of the plus 5x is minus 5x. And then multiplying by 3, so 3y, you want to get that by divide by 3, so you get y equals negative 5/3 x plus 1. So our slope is negative 5/3. Over here, same story. Subtract 3x, and you get 5y equals negative 3x minus 25. Divide both sides by 5 because that's the number in front of the y. You get y equals -3 fifths x minus 5. So you notice these are not the same, so it's not parallel. You notice these are not negative reciprocals, because in order to be negative reciprocals, one has to be positive and one has to be negative. Well, these are both negative. So that means the only option left is either. So good job, you did it. Please be careful. If you use Desmos and just type it in, I don't think it tells you if they're parallel or perpendicular. It'll show you the intersection. It's really hard to see if it's a right angle. Let's just explore for a second. Wolfram